It's great to be here. My name's Eric, and I am Director of Sustainability at CannonDesign. If you haven't heard of us, we're just one of the top 10 largest firms in the world and kind of leaders in sustainability. What I'm going to show you is not done. It's a it's a work in progress. So bear with me. But we're figuring this out for clients right now, and so you're kind of seeing kind of the messy workspace behind the curtain a little bit. But first of all, today's Earth Day. It's the 52nd Earth Day. And this might not come as a surprise to you, but on this Earth Day, we failed. I don't know if you realize that, but 50 years of the modern environmental movement, and we've ended up in the exact spot we did not want to be. This was the headline of the New York Times, June 1988. I just graduated high school, so you can do the math there. But Jim Hansen, chief climatologist at NASA, testified in front of Congress. And in it, he said that we need a sharp cut in burning of fossil fuels in order to stop this climate change. And if we didn't do something, that within the next 3 decades, we were going to feel it. And 33 years to the day, almost, this was the headline of the New York Times: climate change comes for all of us. It should have just said, "We told you so," basically, is what it should have said. A month after this came out, the IPCC released its sixth and final assessment report, what's been called a code red for humanity. So we ended up in the exact spot we did not want to be. We've failed, and there's already enough greenhouse gases in the air to put us over our 1.5 degree threshold. And so despite 50 years of warnings and bell ringing, the only thing that we seem to have accomplished is that somehow we managed to name a bunch of paint colors after climate change, which I guess that's nice. The trouble is buildings, right? Buildings are responsible for half of this, and we're designing buildings around a set of assumptions that are no longer true. In fact, they might never have been true. Here's how I think about it. On the y-axis, we have everything from restorative to consumptive, and on the x-axis, we have everything from degenerative to regenerative. If we're really being honest with ourselves, this is where buildings are, right? They're quite destructive, they're quite consumptive, they're quite degenerative, they make things worse. For the last 20 years, LEED has been trying to be less bad, right? With a goal of really trying to be here in the middle. But we don't want to be less bad. We want to be good. And so what would good actually look like? Wouldn't that be designing for human health, designing for wellness, and truly being restorative and regenerative? Wouldn't that mean that we would be designing the way nature does? That's our aspiration. That's where we should be headed. And it's a much better value proposition at that. It turns out that the air is killing us. It's known as the invisible killer. 90% of the world's population is being affected by dangerously polluted air inside and outside our buildings. And stupid little simple things like just adding air purifiers to an LA classroom can improve student performance as much as if you cut class sizes by a third. And what's worse is that we've seen now that this air pollution, this exposure to toxic chemicals, is also known to damage the development of neurons in the brains of children. Living near a coal plant can shorten your life. And so we're living in a toxic soup, and we keep making it worse. On bad air days, we've seen that surgical outcomes get worse, crime goes up. Even the stock market is affected on bad air days. And the conventional wisdom in our building is to ignore all that, right? We're going to hermetically seal the building. You're not going to be open anything. You're not going to be able to get outside. We're going to seal you in and trap you with all the pollutants. And so I think what we need is a paradigm shift. I think we need to rethink how we look at that, because I think everybody deserves fresh air and views and access to nature, right? We do a lot of healthcare work, and all of our clients are asking us about the future technology of healthcare. We do a lot of education work. They're asking us about what are the future technologies of buildings. And what I keep saying to them is, you're forgetting that nature is a technology. It's a technology that we've been deploying for 3.8 billion years, and we need to keep deploying in a new way. And if we start to look at biology and physics as a technology, maybe we can start to work more in harmony with it. There's lots of definitions of sustainability, right? I'm sure you've heard all of them. Given the audience here, I'm sure you can tell me your own version of it. But this is part of the trouble, is we're not jumping to where the puck is going to be. If we start stacking the trends, like here are the material trends, right? We started with low VOC, that was in the 80s, right? And if you look at the material trends and you stack where they're going, where it's headed is we're going to end up in a bioengineered future. If you look at carbon trends, you can see we started with energy efficiency in the 70s, all the way through Passive House to net zero and now carbon positive. And you start to stack those trends, you can see we're headed towards a carbon negative future. If you start to look at nature trends and sustainability trends, we started with the precautionary principle. Rachel Carson, 1964, right? Silent Spring, all the way through Ian McHarg, Design with Nature. And if you stack all these trends, where we're headed is to be truly nature-based. And then even if you start to look at the technology and fabrication trends, we started with BIM, what, 22 years ago, right? And from that, we've moved through AR, VR, MR, all the way through artificial intelligence. If we stack these trends, we can see where we're headed is to be truly symbiotic. We are one with nature. So we know, if we're really thinking ahead, that the future is going to be bioengineered. It's got to be carbon negative. It's going to be nature-based, and it's going to be symbiotic. You will not be able to see the line between where mankind stops and nature begins. But that's not what we have today. What we have today is a weird flip. Rich Corsi, who's the dean of engineering at Portland State, which is where I live, he has this great quote, and he said, "Americans spend more time inside buildings than some species of whale spend underwater." We spend about 90% of our time indoors. It's kind of crazy. And so far, our response has been to warn you about it. Like suddenly you wouldn't go indoors anymore. It doesn't make any sense. Instead, what we should do is we should stop it, right? It doesn't make logical sense to put cancer-causing buildings together. It just doesn't make any sense. In fact, Einstein has a great quote. He said, "A clever person solves a problem, but a wise person avoids it." So what if we were to take that idea of just let's avoid it? The trouble is that we are chasing after the wrong things. How many times have some of you done a lead building, and in the pursuit of not putting formaldehyde in, you've stripped natural wood out of the building, you've removed biophilic aspects of the building because you didn't want the formaldehyde that came with it? How many times when you've done lead, you wanted to get the FSC credit but you didn't have any wood at all, so you added wood deliberately just to get it? How many times have you gone after the high recycling content credit, and so you've added in 14% recycled vinyl so you could get that, right? So maybe some of these metrics make for bad targets. And so I become very obsessed with this idea of metrics. And I convinced myself that if we change what we measure, we could change the world, right? Because how do we measure success in a building? Isn't it like cost per square foot, revenue per square foot, maybe life cycle ROI, right? Maybe. But how should we measure success in a building? Shouldn't we measure patient recovery times or stress reduction or the amount of staff that we're able to retain? Those things also have value. And how could we measure success in a building? Couldn't we also measure the amount of energy we produce, the amount of carbon we sequester, or even how many habitats we provide a home for? So if we start to look at our metrics, architects and engineers have a lot of metrics that we're very good with. We're very comfortable with these metrics. They're quantifiable. We can point to them, right? We argue about them. We have working groups to discuss them. But what I noticed about these metrics is that only architects and engineers speak these metrics, right? And they only tend to focus on the negative usually. So for example, we don't measure the amount of oxygen in the building. We measure the amount of stuff that's choking out the oxygen. But if you ask us what our clients measure and what our clients care about, that's different, right? What our clients care about is financial, OPEX, CAPEX, IRR, NOI. So you've got two different groups speaking two different languages, and they're not listening to each other. And then if you're doing this in a healthcare facility, what doctors care about is the patients, right? So their metrics are totally different. So now we have three different groups, all speaking three different languages. So what we discovered is that the metrics that we use on our buildings are wrong, and what we need is like a missing link, like something to connect these. And for us at CannonDesign, that's designing to outcomes. I'm not here to sell you on sustainability. I'm here to sell you on the benefits and outcomes that sustainability brings. It's what Simon Sinek called starting with the why, right? So that's what we're doing with our clients. And so what we do is we work with them to map out a series of mutually shared outcomes, things that have value to them, things that are important to them, and then we design to those outcomes. I'm not selling them on sustainability. I'm selling them on the benefits they bring. And if we do that, now you have all three groups speaking the same language, and there's a financial benefit too. In addition, we remind them that everything we show them has some payback. It might not be financial, but it has a payback. And we kind of remind them of that very clearly. And so to me, if we kind of put all this together, what's next is obvious. We need to start thinking of the building as part of the healing, that the building itself would deploy nature as a technology, that the more time you spend in it, the better you'd feel. And it's really kind of a collection of other disparate movements that have been going on in sustainability for years: neuroarchitecture, biophilic design, sensory architecture, evidence-based design. But this idea is really quite a beautiful vision. Imagine a building where the more time you spend in it, the better you feel. So we're designing a cancer center right now for the University of Chicago, and they asked us to design for them the cancer center of the future. And as we got into it with them and discussed, well, what is your vision for that? What are these outcomes that you look like? We realized that it means where the building is part of the treatment, that the idea of healing and the idea of curing should be fused into how we build the building. And so we've broken that into 6 buckets, and I'm going to go through them very quickly because I don't have a lot of time. Um, but Systems, senses, cycles, signals, biomes, and genomes. And what we've discovered is that by deploying this approach to sustainability, we can boost comprehension in students, we can boost immune response in patients, and we can boost staff retention and staff performance. And so systems refers to the 12 physiological systems in the human body. Senses refers to the 30 human senses that we all have. Cycles refers to the 24 hours in a day, our circadian rhythms. Signals refers to the 12 neurotransmitters in the brain that affect mood and appetite and healing. Biomes refers to the 2 microbiomes in your gut and in your brain that we all have. And genomes refers to the 4 geonucleopeptides that make up DNA. It's hard to say. Okay, so here's how it looks, right? In systems, we all have these 12 physiological systems. And what we've discovered is that there are certain things that we could do in the building that affect these systems. Specific things that we could do that we knew that could trigger your respiratory system or your lymphatic system. And if you're designing a cancer center, suddenly that becomes very important. And so we've built this out into a toolkit, really. So we work with the doctors and say, when do we want to trigger their endocrine system? And in case you're wondering, no, we're not triggering anybody's reproductive or urinary systems yet. But anyway, it's turned into this kind of toolkit where we know when we want to do this and we map this out on the patient journey. So that way the experience is one of healing. When patients arrive at the center, we begin that, and that's turned into a toolkit. So we're not making a wall, bright because we like it bright. We know that it's going to trigger a certain physiological response in their body. When we make a wall purple, we're not doing it because we like purple. We're doing it because we know it's going to trigger a specific physiological response in their body. So we're being quite deliberate about it. In terms of senses, a lot of us think that we have 5 senses, the big 5 that we're all taught as children, but it turns out that we have way more than that. We have about 30 senses. We have the sense of pressure, the sense of time. We have the sense of where our body is, right? I can grab my earlobe without looking at it. And so we've been mapping out these different senses and seeing how we can build that along the patient journey as well. In terms of cycles, we've been looking at the 24 hours in a day, the circadian rhythms. You've probably seen this chart before. In fact, you might have even seen this chart, right? How our body changes throughout the day. Our blood pressure is the highest in the morning, it's lowest at night. You might not have seen this chart. These are the proteins and chemical reactions that our body releases throughout the day. So what we've been doing is we've been changing the lighting and the day lighting in the building to trigger these circadian rhythms, deliberately in line with the doctors and the response that they want to get from their patients. And so we've been looking at the lighting in a very kind of bold way. And in addition to doing energy modeling and daylight modeling, we're doing circadian modeling. And this is how it looks. It ends up being a room that changes throughout the day to deliberately fool your body into eliciting the physiological response that we want. In terms of signals, we're looking at the 12 neurotransmitters in the brain. We all have them, and they control mood and they control appetite. But imagine if you're arriving at a cancer center and you're terrified, because most people are, right? You're either about to get a diagnosis or just got diagnosed and about to start treatment, and you're terrified. So the design of the lobby and the reception desk is designed to trigger serotonin to calm you down. As you're waiting in the patient rooms, it's designed to trigger endorphins to boost your immune response. And if you think, well, that sounds pretty manipulative. Yeah, it is. It's totally manipulative. But is this any different than what you do every single day with your vitamins and your supplements and your nutrients and your cup of coffee? You're triggering your brain chemistry, right? So that's what we're doing, but for the good of the patients. And so we're mapping out when do we want to trigger these things along the patient journey and medical experience. Think of it as the building giving you a free hug, I guess, is kind of a good way to think of it. Under biomes, we're looking at the 2 microbiomes that exist in your gut and in your brain, and we all have them. But what's interesting is of the cells that make up you, only 43% of those cells are human. I hate to be the one to tell you this, but 57% of the cells that are you are not human cells. They're other. They're microorganisms, bacteria, viruses, right? Stowaways. They're stowaways that live in and on and around your body, and they live in your gut and they live in your brain. And we all have them. And there's good bacteria and bad bacteria. And you have both. You got both on you, and they help you live. They help you eat and digest. So imagine if we knew this about our patients and we actually designed for it. And so that's what we're doing. What if we were to design for the good bacteria? By the way, this little guy, this guy is called Demodex. You can call him Dex for short. He lives on your eyelashes. He's on your face right now. He's watching this, actually, come to think of it. And he's your little buddy. He's your little stowaway. He's one of the 57% of the cells that make up you. And he helps you blink and secrete tears. And if you think, well, gosh, that sounds gross. Well, you've had him with you your whole life. And is it really any grosser than what buildings are? So what we've been doing is we've been looking at, instead of having surfaces that we need to fight with because of the bad bacteria, what if we had living surfaces that had good bacteria? And what would that look like as a living surface? That means nutrients would go in and benefits would come out. And this lastly leads us to genomes. This idea that we're going to manipulate DNA to grow the materials that we want. Now, this one's probably the most far out of it, but if you think about it, you have binary code as ones and zeros, right? You already know that. But our DNA code that exists in all living creatures on the planet, we also have a binary code, but it's made up of 4 nucleopeptide proteins, GCAT, guanine, adenine, cytosine, and thymine, if you remember your 9th grade biology. And we can swap bits of digital code in DNA just like we swap MP3 files. And I've been talking about this for years, so you might have heard me refer to this. We also call it prostruction. Sometimes we call it made with things that grow. But I think the name that I like right now, my favorite, is built with biology. I think that's probably my favorite way to look at it. And it's why you've seen stories like this, that your next house could be made with mushrooms, which is kind of nice. So we've been kind of mapping out these biological building blocks that nature uses all the time. And so when you see things like pectin, an apple is actually mostly pectin and cellulose with apple DNA woven through it, really. So it's a structure. And so we've been looking at these biological building blocks as how we use them and mapping them and finding products that use these biological building blocks. So for example, this is a product called lignosphere. Lignin is the structural quality of trees, right? It's what trees use to stand up. So lignosphere is taking the lignin from the trees and making it into an all-natural wood-based adhesive. It's a very powerful all-natural glue. This is cruise foam. It's made from chitin. Chitin is the stuff that makes up crustacean shells. It's the stuff that gets its structure. So this is a biopolymer, compostable, all-natural, insulated foam, right? There's a lot of these chitin products. So we've been mapping all of these bio-based products that use these biological building blocks and then deploying them into our buildings. And I'll include a bunch in the slides so you can see them, but they're pretty wild. This one's called Biome. It's made from ag waste and whatnot. This is Biomason. You've probably seen this one. They're growing concrete with bacteria and recycled aggregate. This is Ecovative. This is also pretty famous. This is Mycelium, right? They're using mushroom fungus to grow things. Another company called Biome is doing the same thing. And then we've been mapping all of the old school materials that are low carbon that we've been using for years. You know, I started my career building straw bale buildings, right, which is as low carbon as you get. So we're also looking at that. And then for everything else, we're mapping the embodied carbon of all those materials using Tally and EC3, like many of you. So it's really quite great. And then the last two I want to show you, just because I'm excited about it. This is a company called Opus 12. I wrote about this in the Circular Economy book that we just released. They're taking CO2 from the air and making it into products. And this is a company called New Light. They have a product called Air Carbon. We have an interview with their CEO in the book, and they're making products from CO2 harvested from the ocean, which is kind of amazing. This is another product called Adaptivate, which they're making drywall from old carbon dioxide. So they're using carbon dioxide as a building block. It's kind of amazing. And so there are tons and tons of these new emerging bio-based technologies, and we're really just cataloging them and starting to put them into use. It's kind of an exciting time, really. But it gets us to this idea of built with biology. Okay, that's that's my time. Those are the 6 categories. That's what I wanted to share with you. Like I said, it's a work in progress. We're still kind of learning and growing and evolving this every single day. Happy Earth Day, everybody. I'm hoping this has opened your eyes a little bit to the possibilities of nature as a technology. And if you could start to look at it that way, wouldn't that really be the pot of gold at the end of the rainbow? And wouldn't that make everybody happy? Okay, with that, thank you very much. There's the session code if you want to self-report your CEUs, apparently. And otherwise, thank you all. And yeah, I look forward to seeing you in person soon.